In this video we're going to look at half-life. Radioactive substances decay at different rates. This is because they are unstable to different degrees. We use the term half-life to describe the time it takes for half of the material to decay. Uranium-238 decays via an alpha decay. Uranium-238 decays via an alpha decay. This takes 4,500 million years to decay by half. Its half-life is 4,500 million years. Technetium-99m, which means it's a metastable substance, that will decay via a beta decay, and this has a half-life of 6 hours. And finally, americium, which we'll discuss for smoke alarms, so americium-241 decays via an alpha decay, and this takes 460 years for the amount of americium that you have to decay by half. We call the decay of a substance its activity. It's the decay rate, and we measure it in a unit called the becquerel. This is given the symbol BQ. We can plot a graph of activity versus time. In this typical half-life graph, I have the activity in gigabecquerels and I have the time in minutes. Using the graph, we can interpolate at certain points to find out how long it takes for the activity to drop by half. We do this at a few points along the graph in order to collate some data and calculate an average. If we first interpolate at an activity of 10 gigabecquerels, we find that the time starts at approximately 1 minute, so we'll go with 60 seconds. If we then look at the time it takes for half of this material to decay, so the activity is now 5 gigabecquerels, and we interpolate again, we find that it's just short of 3 minutes. So we'll go for a difference of around 120 seconds. If we then reduce the activity by half and interpolate at 2.5 gigabecquerels, we find that the activity goes from 3 to just over 5 minutes, so around 130 seconds. And then if we were to interpolate at 1.25-ish gigabecquerels, we'd find the half-life to be somewhere between 5 minutes and 7 to 8 minutes. So using the interpolation, if we now look at the time it takes for each half-life to occur where the activity drops by half, for the first instance it takes around 120 seconds, the second instance it takes around 130 seconds, and in the third instance it takes around 150 seconds. Now we average this number in order to find out the half-life of our material. So obviously it's an approximate half-life, and that comes out at 133 seconds for the half-life of the material in this graph.